So hello everyone. So today is going to be our day 10 of the DSA challenge that we took, right? And the question that we're going to take today is find the duplicate number in an array, basically. It's a medium type question. And just a disclaimer, just a heads up for you guys. So basically, if you want to understand this question, you really need to know about the linked list, slow and fast pointer approach, right? So people who are aware of linked lists, right, they would already know how slow and fast pointer approach works. Basically, tortoise. There are multiple names. People say cycle algorithm, tortoise algorithm, and all these things, right? So a tortoise and rabbit algorithm, I guess that's what its name is. So we'll understand that in the optimal solution. But let's start with this question, and we'll see later on, right? So the question states that given an array of integers nums containing n plus 1 integers, where each integer is in the range 1, comma n inclusive, there is only one repeated number in nums. Return this repeated number, right? So this question also states that you must solve this problem without modifying the array nums and uses only the constant extra space, right? So you don't have to use any extra space. Let's forget this line for now, right? Because in the when you are in an interview, when you'll be sitting in an interview, you won't be asked, you won't be the interview won't tell you this line, right? He won't tell you that you don't have to modify the array or you don't have to use any extra space, because if he tells you, then you will obviously go forward with the most optimal solution, right? So also here it is written that all the integers in num only appear once except for precisely one integer which appears two or more times. Great. So let's start with this question, right? Let me take this example, right, and paste it here. Great. If I Let's start with the naive approach. Now, what is a naive approach? Basically the brute force, right? Brute force, right? Great. So if this is the array that is given to you guys, right? What is your first thinking that it would come? I would probably say that, hey, just sort this array. Now, how will the sorted array look like? It would something look like 1, comma 2, comma 2, comma 3, comma 4. Great. If this is the sorted array, um, you can easily traverse through the whole array and check if I is equal to I minus 1, or probably I is equals to I plus 1, whatever you want me, it's on you, right? What you have to do. So you will notice that at this position, if you check for I plus 1, then this will be fine. Then, or else if you check for I minus 1, then at this position, you will find that this position also holds a 2, and you will probably return 2. What is the time complexity for this, right? So time complexity is O of n log n for sorting plus O of n for traversing the whole array and finding out the integer that is there, right? So this gives you the O of n log n plus O of n. And space complexity, since we did not use any extra space, we are using this. But again, at this point of time, the interview might ask you that I don't want you to play around with the array that is given to you, right? He will ask you that, hey, don't like it is mentioned here that you don't have to modify the array, right? You don't have to modify the array. Great. So now if you don't have to modify the array, and you have to improve the time complexity as well. So since the time complexity is maybe not good, right? What you can do is you can have, like an object, you can have a frequency object, right? So if you have a frequency object, right? I'm talking about JavaScript for now. I mean, in other languages, it could be it or something. I'm not sure, but yeah, in JavaScript, you can call it an object, right? And what you can do is, so if I paste it here again, this is the array. Let me start by traversing. Okay, let me start by traversing. This is my first array. This is my first element. Is it present in my object? I will check. No, this is not there. So what I'll do is I'll just have it a key as the number, sorry, the element given, and its frequency as 1. 1 for now because it is not there, right? It is not initializing with it with 1, or else we'll see, right? Then I'll move to second point. Is it present? No, it is not present. So adding it again. 4. Is it present? No, it is not present. So again, 4, comma 1. Is 2 present? No, 2 is not present yet. So 2, comma 1. I'll I'll move to next pointer. At this position, when you check that, hey, is 2 present in my object? Is 2 present in my object? Your answer would be yes, it is already present here. It is already present here. You don't have to increment it anyhow. You don't have to do it anything. You just return this number. Return, return this number, right? You will return this. At this position, you will return. Great. Is there any other better example? Okay, if even if we take this example, it's almost the same. Doesn't really matter. If I paste it here, then again, if we, take this example, is it present? No, it is not present. So 3 comma 1, not comma 1, 3, 3's value will be 1. Then I'll probably move to 1. Is 1 present here? No, it is not present here. I'll add it. Is 3 present? Yes, it is present already, right? It is present already. So this already exists. The property already exists in the object. I'll simply return 3 because I know that. Why am I returning at that position only? Because all the integers and nums appear only once, except precisely one integer. There will be only one integer which appears two or more times. Had it been more than one integer that would appear, appear more than once, I will obviously have to traverse the whole array. Then I will traverse this whole object, and then I will, return all the possible integers that are there which have value more than one. Great. So let's quickly discuss the time complexity for this as well. This takes only O of n traversal because we are only traversing once through the whole array, right? We are checking in the object that if it presents, and it is on the checking is done in O of 1, I guess. Yeah, you don't have to worry about it. So space complexity is now O of n because we are taking another set basically. We are taking a set as it is called in other languages. I'm not sure what it is. See, in JavaScript, a set is called which holds unique value, right? Which holds unique value. So you can obviously take a set as well. You can obviously take a set as well in JavaScript as well. And what you can do is you can check if set if if in set the value of o of sorry value of n I exists. So you obviously return that value. Else you set dot, I guess that's the function, right? You add it, right? So to add in set, you do this. Else, you don't need to take an object. I mean, for me personally, I thought of taking an object. You can take a set as well. In other languages also, you can obviously take a set and you can check if the value is present or not, right? So we are taking an extra space. At this position of time, the interview will ask you, hey, great, you have improved the time complexity, correct? You have improved the time complexity and you have not modified the array. But I want you to do this question without taking any extra space. So he wants you to take O of 1. Sorry, why am I doing it? So he wants you to do it in O of 1. Now, how will you do that? Let's see. Let's see. At this position of time, we are going to use linked list slow fast pointer approach slash uh, tortoise uh, is it I am not sure tortoise or whatever from where I've heard it. It's a rabbit. Um, what's the other thing? The turtle rabbit, I guess. Turtle rabbit approach tortoise approach and what here? And There could be more names as well. I'm not sure. So what I'll do is I'll just keep it here. Great. Now what I need to do is I need to first paste my array here, right? I need to paste my array here. I'm taking a very easy example for you guys. I mean, I should have taken a better example, but okay, doesn't really matter. We can take a better example. So what I'll do is I will initialize my slow pointer as at nums of 0 or array of 0. Why am I taking nums? Because since they were in the question. So and fast also at this position, right? So basically at my if my first index is 3, right? Here it is 3. I am taking my slow and my fast at this position. Great. What I'll do is, I will move my slow pointer by one position. I will move my fast pointer by two positions. So in linked list, I think you are aware of it. So if you move your slow, it will be head dot next, while fast moves head dot next. So head dot next dot head dot next. So it moves two pointers, it moves one point. So this is exactly what we are going to do today. Let me remove this, delete it. I will move my slow pointer with one position and two with this position till when am I doing it? I will do it till my slow is not equal to my fast. So basically, the values of slow and fast are when they are not equal to when they are not equal to each other. I will move these by this frequency. So slow by one and fast by two. Great. Let's see. What is the slow pointer here? Slow is 3. So what is nums of 3 then? What is nums of 3? Nums of 3 will be um, 0, 1, 2, 3. So it will be 4, right? Then what will be 4? 0, 1, 2, 3, 4. It will be 2. What is 2? 0, 1, 2. It will be 3, right? And 0, 1, 2, 3. It will be 4 again. It will be 4 again, right? It will be 4 again. What I'll do is at this position, I will move my point. I will move my point. So slow will move by slow and fast will move by this. Then slow comes here, fast reaches here. Then slow comes here, fast reaches again at this point. So you will notice at this position, my slow and my fast are equal. Great. So 3, 4, 2, um, what is it again? Uh, what was that? 3, yeah, 3 here and 4, right? So if I do this and my slow and fast pointer moves at this position, what I'll do is at this position, when I have reached this position, I will move my fast pointer to this, to my first index, to my first index. Great. When I've done that, right? When I've done that, so what I'll do is I'll move my slow and fast pointer by one position, one position. So slow moves here, fast moves here. So 0, 1, 2, 3, 4, right? Um, so basically, at this position, at at this position, right? I'll check if this is present. What is at this position? This is present, right? Three position. The three is present, and I'll simply return my three. So I hope you understood that at this position, we are having our 3 point, our three answer, and you will notice that yes, at this position only, we are getting the duplicate number, right? I hope you kind of agreed to it, kind of understood what I'm telling you. And you have to, if you have to learn more about what it is, you can probably, you can either search on what is the proof of this, this rabbit turtle approach, or linked list cycle approach, or you can read through this link. I will probably paste it in my description as well. You can read like why always the slow and fast pointer will be equal to each other at some point, right? Cycle, if a cycle exists. So this is a cycle, right? This is a cycle. Every time this will do the same thing. So at four position, then you will again two, three, three again four. This is a cycle. So we have to break out of it, right? And at what position are we breaking out? At this position are we breaking out? At this position, then the answer is when you've gotten your answer, and then we move to this point. At one position, you move it forward, then move, and then when they are not equal to each other, then you will till when they are not equal to each other. And when they are equal to each other, your slow pointer will be standing at that position only, and you have to just return your slope. Right? You can read about it. You can read about the proof of it, like why is it always equal. Let's quickly dive onto the code. Okay. What I'll do is, where, yeah, what I'll do is, I will initialize my slow as array of zero, or as to my fast, I will also initialize it as zero only. Great. Now, if you remember, I asked you that you have to move slow by one position, fast, move fast with two positions, right? One position, two position, right? Now, how do you do that? I will say that, hey, run a do while loop, okay? Do this until, while these are not equal. And while what is not equal? Till slow is not equal to fast. Now, what do we have to do? This is what we need to see. Do something. So slow will move one pointer, fast, sorry, fast will move array of fast, right? So here, if you'll notice, we are moving 2 point, we are moving 1 point, right? So if this is equal point, if when this is equal, when we have reached that position, now my slow and fast are equal to each other. When my slow and fast are equal to each other, what I'll do, I'll say that, hey, fast, simply move to the first entry. Okay, simply move to the first entry. Now what I'll do is, I'll say that, hey, again, slow is not equal to fast. While slow is not equal to fast, I will move my, where did it go? Sorry, yeah. So just simply move my slow pointer by one position, move array of slow and fast also by one position only. Like I told you that when they are when you have done that cycle approach, when you have done that cycle approach where both are not equal and you're moving slow by one position, then fast by two position, till that point, when they are now equal to each other, you will simply move your fast pointer to the first array, to the first element, and now you will move it by one position only till they are not equal. Till they are not equal. So if I remove this, now simply just return your slow position. Because now at this position you will know that, hey, my slow position is the is the element that I have to return, and that is the element that is not meeting my criteria. That is one position, one element only once in the. This is a duplicate element. Basically. This is a duplicate element found, right? We can do a we can do a what do you call it? Dry run as well. A dry run. We can do that. I Let me just okay. So again, if my array is what Do I need to copy? Yeah, I need to copy this. If my array is this, let me do it. Let my where is it? Yeah, slow becomes array of zero, that is t. Fast, let me not write s, show slow full. Let me write s is equal to 3. Fast also equal to 3. Do this while this. First, what is do while do? Do always does that thing first and then check. I hope you know the simple iteration how do while loop runs. It first does the thing and then check, right? So simply do slow is equals to array of slow. Now what is array of 3? Array of 3 is 0, 1, 2, 3. So slow is equal to 4 now. Sorry, slow becomes 4. Uh, Let me erase this. Why do I need to have it? Yeah. And fast becomes array of array of 3. What is array of 3? 0, 1, 2, 3 of 4. What is array of 4 now? 0, 1, 2, 3, 4. So it becomes 2. Great. Is are they equal? No. Again 2. Slow array of slow 0, 1. Let me first what I can do is I can write 0, 1, 2, 3, 4. 4. Yeah. 0, 1, 2, 3, 4. Now what is array of 4? It is 2. What is fast or what is fast? Array of fast. Now what is array of fast first? It is 3. And what is array of 3? It is 4. Now this becomes 4. Now again equal? No, they are not equal. So what slow becomes? Slow becomes array of, it becomes 3. Now what does this become? Array of fast. Now what is fast? Fast is 4. So 2. Array of 2. What is array of 2? 0, 1, 2. It is 3. And now it checks that, hey, is my slow and fast are not equal? I will say, no, brother, it is equal. They are equal to each other. Great. What I'll simply do is, I will, at this position, my fast becomes array of 0. What it is? It is 3 again. It is 3 again. So if my array of 3 is, it becomes 3. Great. Is my slow is not equal to fast? You will say no, don't. They are equal. They are equal. So I will simply return my slow. Now what is slow? Slow is nothing but 3. And this is the required answer. This is the required answer. Let's take this again this example. Let me copy it. Let me paste it. Great. My slow is 1. Fast is 1. Great. What I'll do? I will let me, yeah, here. Great. What does my slow do? Slow is array of slow. What is array of slow? So let me write it. Uh, can I do something? Okay. Or let me do one thing. Let me write it here. 0, 0, 1, 2, 3. Right? I think 0, 1, 2, 3, 4. Sorry. So there are 4 positions. Guess how do I make it bigger? Yeah. I hope you understand what is 0, what is 1, what is 2, what is 3, what is 4. Great. So, what I'll do is I will do this first. Slow is equal to array of slow. What is array of slow? Array of slow is nothing but 3. What is fast? Array of fast. What is array of fast first? It is 3. What is array of 3? It is 2. Great. Again, while equal, no, they are not equal. Again, the do while loop. The do part, the slow is array of 3. It becomes 2. Fast becomes array of 2. Array of 2 is 4. And what is array of 4? It is 2. It is 2. Are they equal? No, they are not. Are they not equal? No, they are equal. So what I'll do is I will move it to 1. And now I am at this point. My iteration is at this point. While slow is not equal to fast, my slow moves 1 point and fast also moves 1 point. So what does my flow become? Flow becomes array of 2. What it is? It is 4. What is my fast? Fast becomes array of fast. That is nothing but 3. Again, are they equal? No, they are not equal. What does my array of 4 become? It becomes 2. What does my array of fast become? It becomes 2 again. Is are they not equal? No, they are equal. Simply return my slow pointer. Return my slow pointer. You could have also returned fast pointer, doesn't really matter. It is nothing but 2. And you will notice that, hey, 2 is the duplicate element here. Let's simply write this code then. Copy. Let me paste it here. Great. Bad. Sorry. Now let's write it. It becomes nums of 0 and fast also becomes nums of 0. Great. Do something while this is not true. What is not true? Slow is not equal to fast. Now, what do I need to do? Let me do. Move slow by 1 pointer, 1 pointer. Move fast by 2 points, right? So, slow becomes nums of slow, while fast becomes nums of fast, right? And while they are not equal, as at this position, slow is equal to fast. So move the fast to first element or index. That is nothing but fast is equal to nums of 0. Great. Now you have to move slow and fast by 1 point each. So while slow is not equal to fast, what I'll do is I will move my slow by nums of slow, fast also by 1 position. So nums of fast, simple. And simply at the end, I will return my slow at this position. You will notice that both elements are equal. Great. Let us simply try to run this. Great. Both the cases are accepted. Let's try to submit it. Why is it taking so much time? Why is it doing so? Judging, okay, and submission. Why is it taking so much time? While it is getting submitted, let's quickly uh, check what is the time complexity of it. So time complexity is nothing but O of n only. Why is it O of n? Because we are running this loop once, one loop, this loop again, two loops. So O of n plus O of n only, O of 2n, but not exactly 2n because maybe they get equal at 1 position, maybe they get equal at maybe this slow is equal to fast becomes they become equal at the first iteration only. So may almost equal to O of n. I am taking the worst case as it get yeah, it has get accepted. So this is the accepted solution that you will see. And what is the space complexity? Are we using any extra space? No, we are not using. So constant, right? We have successfully solved this question. As you can see in the description here, there are two follow-up. How can you prove that at least one duplicate number must exist in number? So how can you can do it? You can probably um, you can obviously by this part, if if this if this solution this if this gets an infinite loop, that means no, they never exist. No, a two point at this position of time, you will notice that no duplicate elements exist. Um, if this doesn't break ever, if slow never gets equal to fast, then then this proves that here there is not a duplicate number. Then if this becomes an infinite loop, then obviously you can prove that, oh, hey, no number exists. But if this becomes equal to each other, they come to the if they come to this line number, then obviously you can say that, hey, one duplicate element exists, at least one, at least, right? And can you solve it in linear time complexity? Yes, we did. Already did, right? O of n. So I think this I have done. I have successfully, you know, told you how to answer this question. So let's write notes here. What you can write is use the low pass pointer approach. First, move low by 1 point, move fast by 2 points. Do this while slow is not equal to fast. Do above mentioned thing while this is not equal to fast. Now, when they are equal, simply move your fast pointer to first index and move slow and fast by 1.2 till slow is not equal to fast, and simply return slow after slow become equal to fast. Simple, simple. Let's save it and cross it and mark this as done. Great. So successfully completed our day 10 question as well. I hope that you understood the approach. You just have to dry run it again and again, again and again to understand this approach. Since this approach is most optimal for LinkedIn, I'm not sorry for saying LinkedIn, for the linked list, you have to search what what you have to do is slow, fast, pointer group, right? And on Google, you will find multiple links, and you can open anyone and you can learn more about the proof, like why at one position at at certain position they will become equal to each other, why slow will how slow is moving by 2 points and fast is moving, sorry, while slow is moving 1 point and fast is moving 2 points, and still they become equal to each other. Since it's a cycle, right? It's a cycle. So fast moves by a sorry, 2a, while slow becomes a. And what is the difference? It becomes a. And you will notice that for this, the iterations that we are doing, a will always be a multiple of iteration, will always be a multiple of iteration, right? We are iterating, right? We are iterating here. And a will always be a multiple of it. So you can simply prove this by this approach, right? So, great. I'll see you tomorrow with this question, repeat and missing number, and we'll solve this question tomorrow. Thank you so much for tuning in. I'll see you tomorrow. Bye bye.